Let's explore the sand and gravel water filter experiment.
Prepare a plastic bottle, sand, gravel, activated charcoal, cotton, and dirty water. First, cut the plastic bottle and invert the top half into the bottom like a funnel.
Layer cotton balls, activated charcoal, fine sand, and gravel inside the bottleneck. Slowly pour the dirty water into the filter and watch the water flow down the bottle.
Compare the clarity of the water before and after it passes through your natural filter. The result is that the water flowing into the bottom is much clearer and cleaner than before.
Layers of materials with different gap sizes help trap various types of dirt and impurities. Activated charcoal absorbs chemicals and odors to make the water safer.
This experiment helps us understand the importance of geological layers in filtering groundwater.
Very elegant. Now, let's see how colors that look like one thing are actually made of many others.
Experiment 17, paper chromatography. We are going to separate the hidden colors inside a simple black ink.
You'll need coffee filters, various black markers, a glass with a little water, and a pencil to hang the paper.
Draw a line with your marker. It looks like plain black, but black ink is usually a mixture of many dyes.
The water will climb up the paper through capillary action, carrying the ink particles along with it as it moves.
Watch the separation. Different dye molecules move at different speeds because of their size and how they bond with the paper.
Every brand of marker has a different recipe for black. Some have more blue, while others are mostly brown or purple.
The colors at the top are the ones that travel most easily with the water. The heavier ones stay near the bottom. This is how scientists identify unknown substances. It's like a fingerprint for chemicals and mixtures of all kinds. Capillary action is the ability of a liquid to flow in narrow spaces without the assistance of external forces like gravity.
Today, we're exploring the greenhouse effect experiment to understand global warming.
Prepare 2 thermometers, a large glass jar with a lid, and bright direct sunlight. Place 1 thermometer inside the jar and seal it. Leave the other outside. Put both thermometers in the same sunny spot for 10 minutes.
Check and record the temperature every 2 minutes.
Compare the temperature difference between inside the jar and outside. The temperature inside the glass jar rises much higher and faster than outside. Glass lets sunlight in, but traps the heat inside.
This is exactly how greenhouse gases trap heat in our planet's atmosphere.
This experiment warns us about the serious impact of climate change on all life on our blue planet.
It's better when it's white. Now, let's generate some electricity using some sour citrus fruit. Experiment 19, the lemon battery. We are turning chemical energy into electrical energy using an acid and 2 metals. You'll need a juicy lemon, a zinc-coated nail, a piece of copper, and a very small light or a voltmeter. The lemon juice acts as an electrolyte. The 2 different metals will create a flow of electrons between them. We connect the negative and positive sides. If the lemon is juicy enough, we should see a faint glow or a reading. It works! We are literally pulling electricity out of a piece of fruit. The acid helps the electrons move from metal to metal. If 1 lemon isn't enough, we can link them together. This increases the total voltage, just like putting more batteries in a toy. That's as much power as a standard AA battery. It's not enough to charge a phone, but it's enough for science.
the metals are actually being consumed in the process. It's a one-way trip for the electrons through the lemon juice.
An electrolyte is a substance that produces an electrically conducting solution when dissolved in a polar solvent, such as water.
Hello, kids. Let's explore the bending light experiment to see the magic of refraction.
Prepare a pencil, a transparent glass, and some clean filtered water available now.
First, place the pencil into the empty glass and observe it.
Next, slowly pour water into the glass until the water covers half the length of the pencil. Look from the side of the glass and observe the shape of the pencil at the water's surface. Try changing your viewing angle to see the pencil broken into different segments.
The result is the pencil looks broken or distorted right at the waterline in the glass.
Light changes direction when traveling from water to air to reach our eyes.
The refractive index change between two environments makes us see the image shifted. This experiment helps us understand light refraction, often seen in our daily lives.
That was refreshing. Now let's head back inside for some delicate chemistry with flowers.
Experiment 16, homemade pH paper. We're making our own litmus strips using the petals of a red rose.
You'll need petals from a red rose, some hot water, a bowl, and white coffee filters cut into strips.
Soak the petals until the water turns a deep, dark red. We are extracting the natural dyes from the flower.
Dip your paper strips into the liquid. Let them soak up the color until they are completely saturated and red. Once they dry, you have your very own pH testing kit. These will change color just like the cabbage juice did. See? The acid in the vinegar turns our homemade paper pink immediately. It's a very sensitive natural indicator. And the soap turns it blue. Science is hidden everywhere in nature, even in the flowers in your garden.
You can test everything in your house with these. Just be sure to ask for permission before testing the juice.
Many plants contain chemicals that react to pH changes. Hibiscus, berries, and roses are all great natural indicators.
Our next experiment is way too big for the lab. Let's take it outside for some explosive height. Experiment 15, Mentos and Coke. This is a classic demonstration of rapid gas release through nucleation. You need a big bottle of diet soda and a few mint Mentos. Diet soda works best because it's less sticky. Set your bottle on a level surface. Make sure you have plenty of room to run back once the reaction starts. The key is to drop all the Mentos at once. I'm using a simple paper tube to release them simultaneously. Look at that height. The carbon dioxide in the soda is escaping all at once thanks to the Mentos. Each Mentos has thousands of tiny pits called nucleation sites where bubbles can form and grow incredibly fast. It's not a chemical reaction, but a physical one. The gas just wants to get out as fast as possible.
Almost all the liquid was pushed out by the force of the gas. That is the power of surface area and pressure.
Nucleation is the process where bubbles form at specific points. The rough surface of the candy provides millions of those points.
Explorers to Experiment 76. Today we are exploring the phases of the moon to understand the night sky. For this you will need a white foam ball, a powerful flashlight as our sun, and a completely dark room. Fix the flashlight in one corner of the room, then hold the foam ball and stand a few meters away.
Imagine your head is the Earth, the foam ball is the moon, and the flashlight is the only source of sunlight.
Raise the ball high and slowly spin in place so the ball moves around your head in a full circle.
Watch closely how the illuminated part of the ball changes shape as you move through each different rotating position.
As a result, you have seen shapes from the crescent moon to the full moon appear right on the foam ball.
The moon does not emit its own light. It only reflects the light it receives from the sun shining upon it. The relative positions between these three celestial bodies cause us to see different illuminated parts each and every night.
This experiment helps us understand astronomical laws and how our ancestors calculated the lunar calendar in the old days.
Hello, kids. Let's explore the Newton's cradle experiment to understand energy transfer.
Prepare 5 identical steel balls, strong string, a support frame, and strong glue. First, hang the 5 steel balls close to each other on the frame so they are in a straight line.
Pull one ball at the end of the row away and then release it to collide with the others.
Observe the phenomenon where the ball at the opposite end is pushed away with equivalent force.
Try pulling 2 or 3 balls at the same time and observe the movement of the other balls. The result is that collision energy was transmitted through the middle balls very quickly. The laws of conservation of momentum and energy ensure the system's total energy remains largely unchanged.
The kinetic energy of the first ball is continuously passed to the last ball through collisions.
The experiment helps us visualize how energy moves and acts upon objects.
From fire to plastic, let's see how we can turn a liquid snack into a solid material.
Experiment 14, milk plastic. We are going to use vinegar to separate the protein in milk to create galalith.
You'll need 1 cup of milk, 4 teaspoons of vinegar, a strainer, and some molds for your plastic.
Heat the milk until it's hot. The heat makes the proteins more likely to clump together when the acid is added.
Stir in the vinegar, you will see white chunks or curds immediately starting to form in the liquid. Pour it through a strainer to collect the solid bits. This rubbery substance is a protein called casein.
Squeeze out all the moisture. The more liquid you remove, the harder and more durable your plastic will become.
Press it into a mold. After it dries for 2 days, it will be as hard as stone or modern plastic. People used to make buttons out of this. It's an eco-friendly way to understand how polymers are formed. Polymers are long chains of molecules. Casein in milk forms these chains when exposed to the acid in vinegar.